Hey, it's Caleb. If you like this video, be sure to subscribe.
Hey, what's up everyone? It's Caleb from Caleb Video Maker 2, calebcareer.com. If you like this video, be sure to subscribe. Yeah, I'm like a broken record. I tell you this like all the time, guys. You just need to click it already. Just click it. Click subscribe. If you haven't made a Google account, make a Google account and then subscribe. And then make 10 more. No, I'm kidding, don't. Just subscribe with one. I mean, whatever. But anyways, this video will be about many-to-many relationships. Boom. And we're talking about designing many-to-many relationships. So, I said a couple videos ago that we have problems when we design many-to-many relationships. They don't work out right, they don't, and I mean, I never really explained why. Well, this video, I'm going to explain why. Let's think of a good example. A college. A class can have many students and a student can have many classes. So we have two entities we have to worry about. We have the class, or let's just pluralize it because it makes more sense. The classes and then the students. So let's just think of an example of a way we would try to design this, and it's not going to work out right, but we'll just try. All right. Here we have a classes table, and we have a specific class such as math. Math 101, whatever, really. So we have math. You can't even read that. My handwriting's so bad. So we have math 101. And then we list all of the people within this class. So we have student number 1, and then student number 2, and then student number 3. Alright, well, we can try that, except what if a student drops out? Well, then we have a null value, which we don't want to have those if possible. And what if we need 4 students? Well, that's not going to work because we only have 3 columns. So, how else could we do it? Well, we could try just having students. Well, then every single column could have like 100 students, and we already learned about the atomic rule. We only want one column to store one value, one student. So, what do? Well, okay, that's not going to work. Let's try over here. Let's try it on the student side. We have a table for students. So we have Jimmy, and he's taking the first. All right, yeah, let's list the columns. So we have the name, and then we have class number 1, and then we have class number 2, and then we have class number 3. Well, that's cool. What if he wants to take 4 classes though? Well, then we have to add a new column. And let's say someone psycho crazy guy takes like 20 classes. So now we have it all the way down to class 20, and then a new person comes to the school, and he only takes 1 class. So now his first class is like math, and then there's 19 columns for that guy who are empty, because we have to have the columns for every single person. We think of it like this. If we drew that out so where you could see it better, we would have a table, and then we'd have the ID of the person, and then the classes. So we'll just put like class 1, class 2, class 3, class 4, class 5, class 6. Let's just leave it at that. And we'll just kind of make rows for these. And we have a new guy sign up. So we have a guy with the ID of 6. And his first class is math, right? And then his second class is geology, and then Spanish, and then fashion, and then biology, and then chemistry. And then we have a new guy come, and his ID is 8, and he only takes science, right? Well, now we have null, 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 empty, nothing. We wasted all of this space. And you can assume that's going to keep happening. So that's wasted space in our database, bad design. So how do we possibly do this? Well, the trick is, because we think of, if we're trying to think of like parent-children, who's the parent in this situation? Well, a class has multiple students, so that would make the class the parent and the students the children. But a student can have multiple classes, so that would make the student the parent and the classes the children. So how is it that this is the parent and this is the parent at the same time? That means this points to a child and this points to a child. So this parent is the parent of this parent who is also the child of this child. Which, that just like blew my mind. I don't even know what's going on. So, the way we do this is we break it up into two one-to-many relationships. So this many-to-many is going to become a one-to-many, and then a second, alright. Okay, just for you guys' information, these colon things, I think the correct way to do that is many to n for like the n keep going on. But just don't worry about that. We'll talk about that in upcoming videos. I'm just writing that for my sake. So we're gonna break this up into one and many, and then another one to many, but the other way. So that is how we fix that problem. Alright, so let's implement that with classes and students. What we need is what's known as an intermediary table or a junction table. They're both the same thing. I'll write that out so you can hear me. Intermediary or a junction. There's also like 50 other names for this table, but I mean, just intermediary table will work fine. So, intermediary. And what that is how we connect our tables. So we break this up into a total of 3 tables. So we have the intermediary table, which is the one I just talked about, and then we have the students table, and then we have the class table. So, class, student. This is the intermediary table. So we have a one-to-many relationship going this way, and then we have a one-to-many relationship going this way. So, one, many, one to many. I know that seems a little confusing at first, but trust me, it'll make sense once we start explaining things more. So we have one to many, and this is the intermediary table. Alright, so let's just draw this connection so we kind of can visualize this a little more. Kind of like split this to see how it works. So we're storing the many side of both relationships in one table. That's because we know that a one-to-many relationship is spread out over 2 tables. So 1, 2, 1, 2. The 2, it's being shared. So what would we name this? We would say, like, we could name it class students, for example. And these, we're going to have foreign keys that point back to the class and the students. So now that we kind of understand what it looks like when we draw it, let's give specific examples to illustrate this. Actually, like what it would look like, whatever. Alright, so let's say we have our classes over here and our students over here. Okay, so first things first. We have math. We'll just keep it simple, math. Science, I mean obviously it'd be more in-depth like Math 101, Math 205, or 1200 or whatever. And then we have English. But just for simplicity's sake, let's say these are the only 3 classes in the college. Alright? Then we have all of our students. We have Caleb, we have Celeb, we have Khalib, and then we have, man, I'm so conceited. All I ever talk about is myself. Alright, let's get rid of my name. Let's go with Johnny, and Jake, and Sally, and Claire. Oh, not Claire. Alright, so here are all of our students for our class. Classes, students. We connect these in the middle. So first things first, we give them all an ID because that will be our primary key. So we'll just give these random assigned numbers, which is pretty much what a primary key is, a surrogate primary key. So we'll give this one 63. This is something our database would do for us. This one will be 75, and this one would be 89. Hopefully you guys can see that clearly. We'll do the same thing over here. So John will have the ID of 8, Jake the ID of 17, Sally the ID of 16, and Claire the ID of 4. Just kidding, 666 because she's evil. 666. I'm just kidding. We'll just go with 6. All right. Now we use the intermediary table to connect these IDs. So we have this table here. We have 2 columns. We have the class ID, and then we have the user ID. And then if you wanted to title these tables, we can make it classes, class students, and students. It's the intermediary table. What an intermediary is, it's something that connects 2 things. It's like it allows this table to talk to that table. So it's a connection between these 2 tables. We put the ID of the user with the class that they're taking. So let's say John is taking English and Science. We would have 8, 75, 8, 89, writing really big, I'm going to run out of room really quickly. And what this does is using this intermediary table, we can figure out that all of these user IDs point back to a specific person, and these IDs point back to a specific class. We are not repeating data because we need to know the user of this class ID. This is a foreign key pointing back to one specific value. So that means if John decided to drop out, well then we have foreign key constraints to get rid of these. That way we don't have to worry about incorrect data or users. I guess this should, I'm sorry, this should be like students, sorry. But we don't have to worry about students who, we don't have to worry about students being enrolled who don't exist. So that is the solution to a many-to-many relationship. This video is getting really long. So Sally could do the same thing. We could say 16 and then 75. She's taking science. Claire, she's taking math. We can keep going on if we really wanted to. We can make this table as big as we wanted. And basically this is the easiest, best way to use as much databasing resources, storage as possible, as well as now we solved the parent-child relationships. That's because we have the parent over here, we also have the parent over here. They point to the child table. So this child table becomes the child of both of these parents. Sort of how in real life, every single person has 2 parents, and the person is this entire row. Okay, so yeah, applying that to this, the parent is the class and the student of the class, and the child is a row where we have both the class and the student. This right here needs to be unique. It's an individual child. We can't have 663 again, because that's saying Claire is taking science and math. Claire's taking math and Claire is taking math. That doesn't make sense. So this right here is unique 63 to 6. You can't have it in there twice. So the child is an individual connection between the parent and the other parent. So yeah, that is how you properly store many-to-many relationships. And I know all these relationships are kind of complex and you don't really understand with like a stupid chalkboard. But like I said, we will be getting into on-screen computer videos in the introduction. I mean, I said that in the introduction. We're not going to do that in the introduction because that wouldn't even make sense. So yeah, we will be explaining these concepts and then we will be applying these concepts to actual databases once we get through all of the database concepts. So yeah, see you around, stick through to the end of this series and you will learn a lot. So yeah, be sure to subscribe. Thank you.